Okay then, good morning, welcome back everybody. How's it going? Hope you're doing well. Hi Yelka. We just have another 2 minutes or so, and then we'll get the meeting underway. But yeah, I hope you guys had a great weekend and are doing. My bad, you see it, my phone, it's on back up there, so the audio a little double, but I just muted it. Okay. I was just saying, I hope you had a great weekend and they're doing well in their other classes and stuff. And just hang back for a minute. I'll be right with you guys. Feel free to say hello or anything you wish in that chat. Hi, Caleb, Ghazi, good morning. Hey, John, Caleb, Violetta, Brianna. Dan the man. Hey, Angel. Okay. Monica, Ryan, Nicole, welcome everyone. Delilah, Roheen, Dan. Good to see you guys. Gabriel, Ashley, good to see you guys. Okay, so it's pretty much 8:30 now, so I'm going to get these meetings underway here today. Thanks, guys, again for being here, and I appreciate all your attendance. Make sure to leave some kind of comment at some point so that I can keep track of it. And okay, so last week, I guess, was kind of media week. We talked about mass media, the internet, and advertising and marketing. I sent you guys some videos, and that substituted for the Thursday meeting. And you'll remember that your third homework assignment is due this week on Friday, anytime by midnight. So that is the fallacies within advertisements homework. And you guys, I mailed you the instructions for that. You still have some time to complete it, but I wouldn't wait to the very last moment since you got to kind of dig around and find some examples. So yeah, basically all you have to do there is try to find a different advertisement, one for each of the different 20 fallacies. You'll have to supply me with, a document that lists the different fallacies, either including the image that you have, whether it's a photograph or a link, or if it's a video ad, then you would show me the link so that I can click through and watch the example. And you would provide a one-sentence explanation for each case as to why it satisfies the definition of that fallacy. And if you do it perfectly well, and you get all 20 examples, then that's 100 points for homework 3. So just a reminder about that. If anybody's working on their homework project and they have any questions for me or anything else, I'm always happy to answer those. So you can send me an email or swing by the office on Wednesdays or Monday. Well, Monday's gone now, but tomorrow, another office hour from 12 to 1. And yeah, so just keeping you up to date and informed on that. You would know if you look in your announcements or just check the syllabus. But anyway, just a reminder to get onto that and make sure to turn it in by the end of the day on Friday. And then the next thing that's coming up after that is the third quiz. That's going to be the last quiz. And then after that, there's just going to be one more homework assignment and then the final. But the third quiz is on chapter 12, which has to do with science, and that's going to be our topic for this week. So we have 2 lectures, Tuesday and Thursday, today and Thursday this week, which we'll use to cover chapter 12, which is all about science and pseudoscience. So the plan for the next couple meetings is we have lecture today, lecture Thursday. Next Tuesday, a week from today, that's when we will have that quiz on this science chapter. And then from there, we have some meetings on chapter 9, which has to do with ethics. After we finish up with that, we'll go over the review sessions and get ready for the final. I'll assign you your last homework, and you'll take the final exam. Okay, so just a couple of quick points on the upcoming dates and schedule. But if that's all clear, then I guess what I'll do is start talking to you about our topic for the week, which is chapter 12, and that's a chapter that has to do all about science. So here we go. Science. Okay, I'll just open my book to the page that I need here. Okay. All right, so yes, in many of the chapters of this book, the beginning of the chapter opens with some discussion of like a real world example or issue to kind of draw the reader's attention to the significance and value of learning the material. And at the beginning of this chapter 12, they discuss the case of global warming. Okay, so global warming, which probably many of you guys know, is a problem that is a growing problem for current day and future generations of humanity. The real issue is that because of human industrial processes, including the burning of fossil fuels and other industrial processes, we emit a lot of carbon emissions into the Earth's atmosphere. That's a byproduct of this kind of fuel consumption. And anyway, when that carbon emits into the atmosphere, it accumulates and creates a greenhouse effect, which causes the global temperature to increase a little bit. And over time, the temperature increase starts to have ecological impacts on the biosystem and on the planet. For example, it causes Arctic sea ice to melt and big ice sheets that we have in the north and south to start to turn into water. Because of that, the sea level increases a little bit. And there's also other resultant effects like of more extreme weather patterns and hurricane seasons. But anyway, one thing that happens for sure is the rise of sea level because of melting Arctic ice. And according to the data we have, the level of sea rise over the last 100 years is something along the line of 7 inches. And according to some pretty reliable estimates and models, unless we really turn this around, we could see as much as another foot or more of sea level increase by the turn of the next century, by the 2100 year. If you look at a graph of global temperature over the last 150 years, back in around 1850s and 60s, when we started to compile this global temperature data, you'll see that the hottest 14 years have all been since the year 2000. And the hottest years on record globally are all in the past decade. So, you know, a graph showing global temperature would see a spike all clustered towards the tail end of the timeline, closer to the present day, which means the trend is increasing. And again, the water rise and the sea level rise is because of melting Arctic ice. So it's a concern because in worst case scenarios, as you could imagine, whole coastal regions could be either submerged in water or facing significant infrastructure impacts from the encroaching sea levels. And since we live in like a coastal area here on the West Coast, for people like us, it would especially be of some concern. So as critical thinkers anyway, we have to be able to interpret and evaluate information that we see from science when it's reported either in the media or in scientific journals. We also have to be able to know a little bit about the history of science. So these are some of the things that we'll cover in this chapter. We'll learn about the history of science, identify some of the major assumptions that science has. We'll talk about the steps of the scientific method and what are some qualities of a good scientific hypothesis or theory. And we will distinguish between what is like good, credible science and junk science, sometimes called pseudoscience or fake science. Okay, so I guess to get this whole thing jumping off, the first item of vocabulary would be the term science itself. Just as with knowledge, we start with definition of knowledge, or with language, we start with definition of language. In the science chapter, let's set the table by considering what does this word science even mean. Okay, so utilizing the way it's discussed in our book, the idea of science is basically this. It's reasoning from observable facts to testable explanations for those facts. Okay, so in science, we reason from what facts we can observe to testable explanations for those same facts. And I see you guys in the chat arriving. Thank you guys so much for being here. Not to worry if you came in a moment late, but good to see you. So yeah, there's our definition of science. Reasoning from observable facts to testable explanations for the facts. So with science, we start with observation. We observe the world, we note that certain phenomena are occurring or are happening, and we don't stop there. In science, you want to observe these things, but you want to be able to explain why they are happening, okay? So like, I mean, imagine that you were a pre-modern person living, you know, back in the Stone Age or something. If there was a solar eclipse and all of a sudden during the time that you'd expect the sun to be out, it's suddenly the world bathed in darkness for a moment. You'd observe this happening, but you had no idea why it's happening. You couldn't explain it. You'd maybe attribute it to some kind of mystical or supernatural phenomenon. If you saw a volcano going off or whatever, you'd see the event, you'd see the magma ejected from the volcano, but you'd have no idea what processes lead to this happening. So science is the business of trying to provide explanations for things. Why does this happen? What is the cause of the thing that we have observed here? And so only by knowing what the cause is can we have a better understanding so that we can prepare for things that we wish didn't happen, or to bring about the good results that we want to happen. So in science, we need to have explanation for phenomena that we observe. And the explanations that we give, we're also supposed to be able to test to make sure that they're accurate. So these are supposed to be explanations that you don't just take the person's word for it. The scientist says, look, here is an experimental test that you could perform, which would showcase that this is a correct explanation for the given phenomena. So science comes together with testable explanations. It's not supposed to be that you just take the conclusions without any further consideration. You're supposed to be able to say, well, here is the evidence that the conclusion is true, because you can perform a test which shows that this is the cause-effect mechanism that leads to that result. Okay, so without having science, we would be at a loss to explain why anything is happening. Why does the sun come up? Why do these volcanoes erupt? Why do we have solar eclipses? How do plants grow and convert sunlight into food? How does the digestion or respiratory system work? How do aerodynamics work? How does light propagate through space? There are so many things that we wouldn't know, and there's so much technology that we would never be able to master because we wouldn't understand the principles according to which electricity works, or the principles according to which thermodynamics works, or anything else. So having this knowledge gives us power to be able to control certain factors in the world to suit them to human needs and interests. So anyway, science. It's a very important concept. Obviously, science you could consider to be the major source and method for getting any knowledge or information about the world. If there's something about the world that you want to know how it works or what's going on, the best place for you to go would be to your scientific consensus theory of that thing. So if you're wondering, how is it that plants grow? How does the reproduction process work? How does global temperature contribute to the existence of weather phenomena? What is up with the orbit of the celestial objects in space? If any of these questions interests you, then it's science that you would best turn to get yourself the clearest and the most current day explanation. So obviously, for those of us interested in knowledge and having a sense of what's true and false, critical thinking is all about that. So science is a major tool for us. But science hasn't always been elevated to the level of respect and I guess just general acceptance as it is today. If you go back in the history of the Western world, prior to the around 17th century, prior to the late Renaissance and the 1600s and stuff, the church in the Western world, the Christian church, was the primary source of all higher learning and knowledge. So today we take it as a given that there's this thing in the West of like liberal democracies having a separation of church and state. So you can go to your Sunday school or whatever your church or religious community is and learn lessons from scripture or from the holy texts. But then when you come to school, if it's like a normal state-sponsored, state-funded school like this, you're taught secular lessons that don't necessarily try to weave together biblical messages or religious messages. But back in the day, in the early history of the West, if you start from the beginning of the Common Era around the year 0 all the way up through the medieval period, the church was the dominant institution, and there was no separation of church and state. So if you were a student, all your lessons would be interwoven with ecclesiastical and theological messages and lessons too. But that influence of the church starts to wane a little bit in the late Renaissance, and that's when science starts to kind of emerge and have a more significant role in shaping society and the way we function. Some of the early figures in the Western history of science that are mentioned in the book, I should put some of them on the board so we can understand their contribution. So here are a couple of important early figures from Western science. Okay, so one of these is Nicholas Copernicus. Okay, so first of all, Copernicus lived from 1473 until 1543. So that's 70 years there. And let me tell you what he did. He's, in some circles, credited with kind of launching the scientific revolution with his discovery of what's called heliocentrism. So Copernicus discovered the heliocentric, let me say one more thing. Polish astronomer, just so you understand his like geographical background. Polish astronomer who discovered the heliocentric model of the solar system. Which replaced the older geocentric model. So it replaced geocentrism. A Polish astronomer discovered the heliocentric model of the solar system, and that did replace the older geocentric model. So yeah, what do you think that means? I'll tell you for sure, but if you had to guess, and I think you might have a reasonable, educated guess, what do you think it is, the discovery of heliocentrism? What do you think that discovery was that Copernicus made, which is a landmark kind of discovery? Heliocentrism, this is a certain model of our solar system, and it's the correct one. But what was this new understanding of the solar system? Heliocentrism, any guesses? It means what? Just take a wild guess. Heliocentrism, any thoughts? Yes, that's right, Gossi, that the sun is at the center of our solar system. Correct. And since that replaced geocentrism, does anybody have a guess as to what the geocentric view was? Okay, Gossi, I guess you've given it. On the geocentric model, the Earth would be at the center and everything would revolve around us. Now, basically, Copernicus and also another figure, the famous Renaissance scientist Galileo, Copernicus and Galileo, using newly invented telescopes that were just coming into use at that time, were able to observe the orbits and motions of the celestial objects and could determine based on their observations that yes, we orbit the sun as do the other planets in the solar system. And that completely reversed the earlier thinking that the Earth was at the center point. Geo meaning Earth, centric meaning centered. So helio means sun. Sun-centered was the discovery, and that replaced the older thought that the Earth was in the middle. Now that might sound to you like, oh, it's obvious. I mean, we all know that the sun is what we all rotate around. And yeah, today it's considered an obvious given, and we have much more powerful tools to conduct clear observations of the organization of the local cosmos, so we know this is true. But back then, I don't know, you might be surprised to learn that it was actually very important for the community in the West to believe that the Earth was in the middle. Why? Well, it was out of deference to what they thought was religious orthodoxy. The belief of the church and of society was God, if he's the creator of everything, and if he's the, created the universe specifically for the sake of humans to inhabit it, and we are created in his image, then they believed that God would want the planet Earth to occupy the most central position. We should have pride of place, right? So we should be in the middle, and everything revolves around us, literally. So it was actually considered quite unorthodox and contrary to religious doctrine to say, to avow that, no, we're not in the middle. We're not in this privileged or special position. In fact, we just rotate around this central point of the sun. So it was actually so controversial at the time to advance this new thought that the sun's in the middle, that people like Copernicus and to a greater extent Galileo were persecuted for their views. Galileo, who learned the same stuff and talked about it in his work, was forced under pressure to publicly recant his testimony, meaning that he had to go out in public and say, even though he's like in his 70s at this point and like half blind from looking at the sun through telescopes, he was threatened, with death and execution if he didn't go forward and say, okay, everyone, listen, I must have been tempted by Satan or something. I don't know what I was thinking. That's not true. The Earth's not rotating the sun. The Earth is in the middle. So he had to go out there and kind of disclaim all of his actual discoveries. In the centuries after this, the church has like formally apologized to Galileo and his descendants, because now all sides are totally in agreement that that we do not sit at the center and rather rotate around the sun. So anyway, this is, in some people's judgment, the Copernican Revolution. It's such a revolutionary discovery because it kind of showed that science and observation could contradict and debunk religious ideas that were held dear to earlier generations of practitioners of Christianity and other religions. So it kind of gave the independence and space for science to grow and develop. And that starts to lead to major advances in the academy and in the world of higher knowledge. We start learning about calculus, we start learning about Newton's laws, the cellular composition of biological matter, anatomy, even fields like geometry and the realistic depiction of objects in art, all starts really advancing at rapid pace as the medieval period ends and the Renaissance kind of ends and the Age of Reason begins in the West. So this is a major monumental discovery, and he gets a lot of credit for that. Okay, so that's Copernicus. I mean, can you imagine that? Living in a world where saying something as basic as the Earth is not in the middle of everything could almost lead you to being executed. So we're living in a different world now. Interesting. Okay, another important figure in the early Western history of science is Sir Francis Bacon. And so he's a British, as you can tell by his title, a British citizen who lived from 1561 until 1626. And his major contribution is that he's credited with formulating the steps in the scientific method. Okay, so the scientific method, something that we usually learn about pretty early in our schooling. The basic core concept of science, that you start by observing things, then you try to create a hypothesis to explain why that thing happens, and then you try to develop some type of test or experiment that could verify the hypothesis. The familiar steps of observation, hypothesis, and experiment derive from the writings and ideas of Sir Francis Bacon. So this is the core methodology by which science pursues knowledge and information, and we, of course, use that method to this day. So we can't underestimate or understate the value of this contribution. Let me read a few things from about both authors here in the book. Nicholas Copernicus, Polish astronomer, launched the scientific revolution with his assertion that the sun, not the Earth, is the center of the solar system. Many historians recognize English philosopher Sir Francis Bacon, who systematized the scientific method as the father of modern science. And Bacon's scientific method, which begins with carrying out observations about the world and using test and experiment to draw inferences that are based on the observations, has been tremendously successful in advancing our knowledge about the world and our ability to manipulate nature. So why is it that we're even able to have this conversation through a computer? And why does such technologies exist? It's because of the discoveries that scientists have made, whether it's with respect to electronics or electromagnetism, you name it. Any technological innovation doesn't just pop out of the sky by magic. It's the result of scientific practice and understanding of cause-effect relationships in nature. So I guess we all have some debt of gratitude to these earlier founding fathers of science. Okay, so we've talked about at least two. I mean, we could have talked about more. I kind of gave the indirect reference to Galileo there too, but some important figures in the early history of science anyway. Now, the next thing to talk about are what are some of the major big assumptions that are built into the practice of science. There are certain baseline assumptions that science has to make in order for scientific investigation to even happen, but we want to point out and understand what those major assumptions are. So this is now going to be assumptions behind science. Okay, so what are some of these? One of them is a term that we've actually talked about earlier in this class, and that is empiricism. Empiricism, one big assumption behind science. And what is it? I think we've talked about it earlier when we spoke about both about the concept of knowledge, right? And also, yeah, does anyone have a memory? What is empiricism? It's the belief that most of our knowledge comes from what type of source? Let me know. What could it be? You'll let me know. Just checking in with you. Empiricism, one more time. What was that? Yeah, let me know just anytime. Empiricism. Well, Violetta, you say from observations. Yes, but this is not a full sentence. I wonder if you have the full statement there in reference to what is from observations. Basically, you're kind of there. I just would have wanted hopefully maybe a more full sentence or statement of what's been defined. Nicole, most human knowledge comes from, no, Nicole, that's the other thing. That's rationalism. That's the opposite. Okay, so Ashley, you have it. Well, comes from the five senses and observation. Did I ask where does most knowledge come from? You guys are talking about where something comes from on the one hand, but you're not saying what it is. And then Nicole, you say what it is that it's coming from this, but you gave the wrong explanation of it. So let's have the right statement all the way through. Most human knowledge comes from where? See, Nicole, your definition starts off the right way, but then it gives the wrong explanation. And in the other cases, there's a proper explanation, but it's not been said what's coming from that. So I just want one correct sentence that says this out. Most human knowledge comes from, and then we can write it out as you have, Ashley, from the five senses and observation. Yes, but here's something I noticed, Nicole. This is a minor point, but in grading a lot of the answers from you guys' midterms and quizzes and stuff, people are using observations in the plural. Five senses and observations. It's a singular because it's a concept. The concept of observation, not like point by point. But it's a minor thing. But anyway, okay, good. So empiricism. Most human knowledge comes from the five senses and observation, singular. Okay, most human knowledge comes from these places. Five senses, and what we can observe using the five senses. There we go. So that's a core assumption of science. As you guys know, science is all about starting through observation to observe the world, collect data about what is happening there, and then to try and provide explanations for these observed phenomena. So if we didn't think that we could get knowledge by doing observation and using our senses, then science would have no ability to discover anything, right? So because it's all observation based. It's based on observation of information and facts, developing hypotheses to explain why those things happen, and then trying to create experiments and tests that could verify that the hypothesis is true. So we have to assume then in science that these methods of collecting knowledge by means of observation and the five senses has to be believed to work. Otherwise, what would be the point? We'd be observing things, collecting data, but not getting to the truth. If that did not lead us to knowledge or truth, then there'd be no value in doing science. So one assumption is that we can get to knowledge and truth using observation and the five senses. That's just what empiricism says. Okay, now another major assumption of science is what is called objectivity. Okay, now the idea of objectivity is the belief that we can study the physical world and that we can learn about it as it really is, not just as it appears to be, but that we can get to the real ground objective truth about how things are, and that we can discover that with no bias. So the belief that we can learn about the physical world as it really is and without bias. So the belief that we can learn about the physical world, the universe, as it really is, and with no bias. So there's a distinction between these two concepts, the objective and the subjective. I believe that you probably have at least some working understanding of what the difference is between like an objective and a subjective statement or claim. So let me try and bring that back into your consciousness with a few simple questions. If I was to ask you, or no, not ask, but say, suppose that I say this statement: vanilla is the best flavor of ice cream. It's the best ice cream there is. Would you say that that sentence or statement is an objective or a subjective statement? The statement that vanilla is the best ice cream. Is that subjective or is that objective? What would you say if you had to take a pick based on your comprehension of those words and the example? Saying to you that vanilla is the best ice cream, is it subjective or not, or is it objective? Okay, good, Nicole. Yeah, subjective, correct. And since you seem to have the right idea here, can you or anybody else expand on that? Like, what would be your reason for saying that's subjective? When I say that vanilla is the best ice cream, what makes that to you a clear example of something that's subjective to say or to claim? Why is it subjective? According to your way of putting it, why would you say it's subjective? That's right, but I'm just seeing how you would explain that as your answer. Let me know. What does it mean to you that it is subjective? I mean, just let me know. Okay, so Nicole, subjective is based more on a personal opinion rather than just facts. Correct, yeah, so subjective stuff has to do with your own individual point of view. And so me saying that vanilla is the best ice cream is subjective because it has to do with my taste and my preferences. I may say to you, vanilla is the best ice cream because it's very neutral and it goes well with toppings and it's good for like a la mode pie and stuff. And then you may come back and say, no, I don't believe so. Vanilla is the most boring. I mean, it really doesn't taste like much. There's so many more interesting flavors if you look at the wide world of ice cream. Now, you have your opinion and I have mine, but neither one we can say is an objective fact because we're allowed to have different views about what we think is the best ice cream flavor. But what if I say to you that the planet Earth is the third planet from the sun? Is this subjective or objective? This other sentence, not about the flavor of ice cream, vanilla being the best, but just that we are the third planet in terms of how our distance out from the sun. Could this be claimed as subjective or objective? Just giving you another example as a piece of contrast. But what would you say there to my new statement? Not about ice cream, but about our position relative to the sun. Third planet from the sun, is that subjective? Is that just my opinion and you can have a different opinion and we can just each have our own different way of looking at it? What do you think? Yeah, that's right. That's objective. It's like maybe there's some people who are like, I don't know, have lost their mind or they're just heavily influenced by drugs or something else, but it's just a matter of fact. It's really not up for debate. It's not something that we can agree to disagree about. It's something that is a matter of fact, and it's something that's provable, so it's an objective thing. Now, coming back to our definition here, science assumes that there is an external world which is objective, and that it's not just all based on subjective perception and your skewed or biased perspective and point of view on reality, but there is an objective reality. We can actually discover about how things as they really are, not just how they appear to be to you, but how they really are objectively, and that we can get to these conclusions without bias. So science believes that with scientific research, you're not just exploring your own opinions and views. You're trying to get to the objective truth, whether you like it or not. So science is not trying to cater towards your preferences or your desires. It's rather just trying to discover objective facts. And sometimes those facts are unpleasant even, consider like global warming. Nobody wants to believe that their planet is threatened and the future is at risk. But science is just trying to tell you, well, that's the objective fact. It's not about whether we want it to be true or not. So science anyway assumes that we can get to that truth, that we can get to the objective truth, and that we can do it without bias. What would be the point of science otherwise? If it was just this sort of game of everyone talking about their own feelings and their own perspectives, but we didn't think we could ever get to the objective facts, then there would be no real reason to do it. Science at least holds forth the possibility of discovering truth, discovering objective truth, and that we can get to it without just reflecting our own private and personal skewed perspectives on things, okay? So science doesn't assume it's like a opinion game where different people just discuss their subjective opinions, but rather that we can use observation, data, and testing to discover objective facts. Okay. The world, if it is objective and it doesn't depend on the subjective point of view of the individual, it should be possible to discover those objective truths through systematic observation. Okay, so another assumption of science, that we can get to that objective truth. Another major assumption behind science, as we continue along this list, is what's called materialism. Okay, so materialism in science and in philosophy is a word that has a specific meaning, and I need to let you know that this is one of those words that has a different meaning that's outside the realm of science and philosophy. So we have to kind of distinguish the different senses of the term. Remember, we learned about equivocation, guys, and earlier with language, we learned that there's sometimes one word with multiple different definitions. Well, materialism is kind of like that, and I want to make sure that we set aside and don't get confused by a meaning of the word that has nothing to do with our class or with the scientific or philosophical meaning of it. Because sometimes when people use the word materialism, perhaps you've heard of people being described as materialistic, like they just care about their appearance and the things that they own and the way that they look, and so like a superficial kind of person that's all about appearances and possessions. But that's not the meaning of materialism that's relevant to our course and our topic. So please, if you see this word and you started thinking of that, let's set that aside and replace the understanding, at least in our class, with the scientific meaning of it. So what is materialism in the scientific and philosophical sense? It is the belief that everything in the whole universe is made out of physical matter, even including us and our consciousness. Okay, so here it is. It's the belief that everything in the universe is made out of physical matter, and importantly, including us and our consciousness. Okay, so that is our definition of materialism. Everything, not just most of things or some things, but every single thing in the whole universe is made out of physical matter, and that even includes us and our consciousness. So that's another assumption, a base assumption of science. Materialism is therefore being used in the sense of like matter, physical matter. Now, here's a question, guys. If anybody knows this from general knowledge or from some primary studies in physics, what would you call the most basic unit of physical matter? So if you were to like break down matter into smaller and smaller pieces, when do you come to the last thing that can't be further broken down? What do they call those things? The tiny, tiny little particles that are claimed to build up everything else. What's the smallest unit of matter? What's the term for this, if anyone knows? You know, tiny, tiny, tiny little infinitesimal bit of matter. That's right, Violetta. We call that the atom. Now, I know maybe some of you guys have studied more advanced physics and you've heard about subatomic particles like quarks and stuff. Fair enough, but let's just go with the word atom because this is the classical term for the smallest piece of matter. In fact, the word itself, if you go back to ancient Greece, refers to something that cannot be cut, uncuttable. Is literally the meaning behind the word atom. And so you're supposed to be thinking then of something that is so small that it cannot be further divided into pieces. And so it's the smallest unit. Now, anyway, materialism, in a way, says that everything in this whole universe is made out of matter, which means that every single thing is basically made out of atoms, put together in a particular way, and then that aggregation or grouping of atoms compiles to form the object. So you see this here hydro flask that I'm drinking out of. It's a nice hydro flask. I got it as a gift, and I'm really kind of stoked on it. I've been using it all the time. I don't know, it's keeping all my drinks cold. But obviously, what's it made out of? I mean, we could talk about the materials and the different kind of metals and stuff that make it. But at the base level, according to the physicalist idea, the materialist idea, it's a bunch of atoms. And the atoms are assembled in certain ways so that they form a thermos, or in this case, we'll call it a hydro flask. So the bundle of atoms put together flask-wise is this object right here. But me, talking to you, and you listening to me, are also, according to this view, just a big bundle of atoms all pieced together to form the object. And the object that I am is this biological life form of a human species member that can give a lecture, and likewise to you. You're another member of the human species. But what you are is a big bundle of atoms all piled together to form that object, which, when it's aggregated, exhibits the features of consciousness and etc. and the life functions of a being like you or me. So importantly, on the materialist way of looking at reality, everything's just physical. There's nothing that's not physical. So what this is denying is that there is something like a consciousness that could exist without a physical basis. So on a materialist picture, your ability to have thoughts and right now perceptions, memories, anything going on in your head in your mental life. On the physicalist way of looking at reality, that's just brain activity produced by the physical brain and its neurons and synapses and stuff. So according to materialism, if there was no functioning brain, then there could not possibly be consciousness. It's not like consciousness, according to this idea, could just be floating free somehow without a physical basis to give rise to it. So where there's no longer a functioning brain, or the brain turns back to dust, through decomposition and decay of the body after death, then there wouldn't be any consciousness left over, because according to physicalism, there's no such thing as souls or ghosts or spirits, because those would be non-physical, supernatural things. And materialists say that no, there's just matter operating according to the laws of nature, and that's the only thing that does exist. So packaged together with the materialist view is the denial of the supernatural, of the concept of the soul, or the idea of a disembodied consciousness that could just be somehow detached from a functioning brain. So it's an assumption of science that there's nothing that's not physical, that everything is physical, made out of matter, and even including aspects of human consciousness, which normally we may think of as having nothing to do with matter or with physics or with atoms. But according to materialism, that's all there is. And so everything, whether it's a human being or a marker or a thermos or a whiteboard, they're just different ways that atoms could group. But there's nothing about it that's non-physical. Okay. In some writing on this topic, you'll see materialism referred to by a different label of physicalism. In my own opinion, physicalism is the better terminology to use because materialism, like I said earlier, carries with it these false associations of the non-scientific meaning of materialism, like people obsessed with possessions and their appearance. Physicalism avoids those other connotations, but since the textbook uses this term, I'm just going to be consistent with the text. Materialism, but aka physicalism. The idea that everything's just made out of physical matter, even the mind. Okay, so that's another major assumption of science. And in the book, I'll read a small piece about that. Well, let me say also something about objectivity, just to kind of be thorough. With objectivity, the one that was mentioned before, the book says this: an assumption underlying modern science is objectivity, the belief that we can observe and study the physical world out there as an object outside of us without bias on the part of the scientist. Because the world is objective and independent of the individual, the presumption is that systematic observation will lead to agreement among scientists. Okay, and then materialism. With the doctrine known as materialism, scientific materialists argue that everything in the universe is physical matter. And they make mention of what I said here. Materialism in this sense has nothing to do with being obsessed with acquiring money, consumer goods, and material things. According to scientific materialism, perceptions, thoughts, and emotions can all be reduced to descriptions of physical systems such as brain waves or stimulus and response. There's no need to bring into scientific descriptions and explanations non-material concepts such as conscious mental life. Okay, now another major assumption of science that follows after this is what's called predictability. So let's get into that. Predictability. This one's interesting and a little philosophical too. So the assumption here is that the universe overall is orderly and predictable, which means that established cause and effect relationships would be repeatable and would hold forever. Okay, so let me write that and talk about it. The universe overall is orderly and predictable. So, established cause-effect relationships will be repeatable and will hold forever. Okay, so let me just make sure to underline all the key points. The universe overall is orderly and predictable, meaning that established cause-effect relationships will be repeatable and they will hold forever. Okay, so to illustrate, I'm just going to try and use some easy enough examples here with the materials that are surrounding me. So I'm holding this marker, as you guys can clearly see, and it's in my hand, it's in my grasp, floating above the table here, about 1.5 feet up. Now what I'm saying is that I'm going to release my grasp. I haven't done it yet. Here it is, it's still in my hand. But I'm going to open my hand and just release my grasp on this marker. Now when I do that, I would love to know, what is your prediction of what will happen? That one shouldn't be too hard. So if I let this thing go, what do you predict would happen? What do you think? Because I haven't done it yet, so it's predictions time. Any wild guesses? If I was to let this thing go, what would happen? You say it will fall on the table. Okay, Nicole, good. But let me just ask some follow-up questions. How do you know it's going to fall on the table? I haven't done it yet. So what makes you think that's going to happen? I mean, can you know the future or something? You're like a psychic. How can you tell what's going to happen when I release this? I have not done it yet. So what makes you so confident? What about that? What's the reason you say that it's going to fall? Okay, because of gravity. Good answer, Nicole, but I'm not done yet. What makes you think gravity is going to operate today? I mean, it was doing its thing yesterday and all the time up till now. But how do you know it's going to keep on working? Wait, you said it's going to fall. What do you mean, Violetta? I don't get it. Me saying something, what difference does that make? I mean, what's the comment in reaction to? Because my first question was, what do you think is going to happen to it? And then you say that it will fall. And I ask you, what makes you so confident that it will fall? Okay. Are you saying you're confident that it's going to fall because I said so? I don't have any power to, I mean, what if I tell you it's going to float? Me saying that would not make you so certain, because that would contradict your prior observation of similar events. So really, you think, again, Nicole, that it's because of gravity. Gabriel, you say it's because gravity is real. Sure, no problem with that. But what makes you so certain that it's going to keep on being real? You know, like I'm talking about before and after. You're saying, oh, it is real. Sure, I can agree with you. But how come it's going to be real tomorrow or after I drop this? I mean, what if it just stops working right now? The function of gravity just stops. What makes you so sure that it won't stop? Okay, so Delilah, because it has happened many times before with other objects too. Okay, now just understand, I'm going to be very annoying and keep pursuing these devil's advocate questions to make a point. Caleb, you say science allows us to make reliable predictions on how certain events will play out, the objects with smaller mass being attracted to those with larger mass, the Earth. Yes, Caleb, I understand this, but I'm getting deeper than that. My question is to you, although that has been true heretofore up till now, what makes you so certain that the same kind of phenomena will work in the same way going forward? Up till now, that's been the case. What makes you so sure that it will happen going forward? And then Nicole, you say because gravity always works and it will continue to work because it has not stopped before. Okay, so good. What I'm trying to bring you guys slowly to become aware of is that you are making this assumption. You are making this assumption. This assumption is the answer to my question. Like, why do you think that the phenomenon of gravity will work today? Because you assume that that process will hold forever. And that since we understand how the cause-effect relationship works, that it will never stop working in the same way. Now, we haven't been privy to the future yet, have we? But we are making an assumption, aren't we, that the natural laws are not temporary laws, that they hold not just today or up till now, but that they will continue to hold forever on and on into the future. So let me try and see what will happen. Just as predicted, it did fall. It did, in fact, fall. So I guess your prediction held in this case. And the assumption you're making is not that it would just happen one time or two times, but if I had infinite time, wouldn't that be great, to keep on doing this, you believe that how many times would it fall? Infinity times, that it would never, ever function in a different way, that there would not even be one example case where I would let it go and it would stand there floating or turn into a chicken and just fly off into the sky. You assume that none of those other weird, absurd things are going to happen because you think that the phenomena of cause and effect, where an object, released from a freestanding height falls, that same cause-effect connection would exist, not just today, not just tomorrow, but forever into the future, and not just here. If we had similar physical conditions, let's say on another Earth-sized planet in a different part of the cosmos, and we had the exact same parameters in place, then in that case, a being dropping a similar object from a similar height should also see that the object would fall. So we have to make this assumption that the laws of nature and physics and so forth exist forever, and that they don't just cease to function or that they're temporary in how long that they work. We can't know this as an absolute fact because the future is lying out ahead of us and we have not yet gone through it, but we assume as much because, again, science cannot perceive the scientific laws to be temporary or unstable. If they were, I guess we wouldn't know it yet because the ceasing of their function would be out ahead of us in the future. But we assume that that will never happen, even though it's not something that can be absolutely proven. If the natural laws were to vary or to change overnight or something, then all bets would be off and all of our past scientific explanations would no longer have any function. But we assume that that's not going to happen. Okay, so predictability. Let me read from the book on the same point. Scientists have traditionally assumed that the universe is orderly and predictable. The universe consists of interconnected causal relationships that can be discovered through observation and reasoning. So yeah, when we've identified a cause-effect relationship in nature, it's not something that's just here and now, but forever, for all time, and at all places where the same kind of cause-effect nexus can be replicated. Okay, so that's predictability. Now, just one more of these basic assumptions of science, and then we'll move to the next section of the notes. One more is known as unity. So the scientific assumption of unity is this, that there is an underlying unity to the universe, meaning that everything could be explained eventually according to a single set of scientific laws. Okay. So, unity. The assumption in this case is that there is an underlying unity to the universe, meaning that everything can be explained according to a single set of scientific laws. So scientists assume that even though we haven't quite gotten there yet, that eventually we will be able to comprehend the natural laws of physics and nature, and that these laws will govern the behavior of every event, from the biggest down to the smallest scales of reality. Because we live in one universe, the assumption is that there should be one set of laws that that govern the operation of everything. But as of today, we haven't quite gotten to this outcome yet. This is kind of like the holy grail of science, the achievement of this unified set of natural laws. In fact, there's an acronym for that, and the acronym is GUT, which stands for Grand Unified Theory. The Grand Unified Theory is like the ultimate goal of modern science, to build or to discover the set of natural laws that explains everything. Today, we aren't there, and here's why. Because we have kind of two different set of physical principles that describe different scales of reality. So at the largest macro scale of reality, we use the work of Einstein and the theory of relativity, so special and general theory of relativity, the electrodynamics of moving bodies. Einstein's work describes how large-scale objects in the universe function and operate. But on the tiniest little nanoscales, we use quantum physics. And there are actually some inconsistencies between quantum physics and relativity theory on the margins. So we haven't yet been able to build a bridge between the two fields, and that's work for future scientists to achieve. But anyway, the belief is that ultimately we will get there at some point, because why should it be that there are two different and distinct sets of physical laws, one for the small scales and one for the larger scales? So since we live in a unified world and universe, the belief is that we will eventually get to that point where we can use one set of laws that could elegantly describe all material phenomena, from the little behavior of quantum particles all the way out to the behavior of galaxies, superclusters, and stuff like that. Okay, so hopefully we'll see progress on this in the next century. So from there, I just want to talk to you guys about what are a couple of limitations of science. these are things that, again, science has to kind of assume, but cannot prove. And some people find these as points of critique against the field of science. So what are some of the limitations of science? Now, I don't want to create like a bunch of detailed notes for this part because it's kind of philosophical, so it's a little easier to just sort of talk to you about it. But I'll write a few brief notes anyway. One of the limitations of science is that it assumes that the external world exists. Of course, this must be assumed, but that cannot be absolutely proven. Okay, so Eddie. Okay, so science assumes that this external world that you're a part of exists and that it's real. That you're not, for example, living in a matrix right now or a simulation, that you're not just in the midst of a big, very detailed, elaborate dream, that you're not, you know, having a total hallucination about reality. So the existence of the external world, like look around you right now, the room that you're in, the building that you are in, the city that you're in, even your body, you think all that stuff is real, that you're not just dreaming it. And of course, science would agree with you that there is this external reality for us to explore, to discover objective facts about, and all the rest. But if we did not think that there was an external world, suppose for the moment that you are just dreaming right now, and there's no such thing as reality and it's all fake, then there would be no point of science, right? Imagine Mario from the Mario Brothers starts trying to do scientific experiments on the mushrooms in the Mushroom Kingdom. There would be no point because he's in a whole fake environment. So the knowledge that he could discover would not even be real knowledge because it's not about anything real. So if we were living in a simulation right now, there would be absolutely no point to all our scientific discoveries because they wouldn't even be about the real universe. So anyway, science assumes that we're not in some kind of illusion like that, but that we're in the real world. It's not just a fake made-up mental apparatus surrounding you. And that's something that has to be assumed in science because what would be the point of scientific research otherwise? But obviously we cannot absolutely prove, or you cannot absolutely prove that you're not in a simulation. Because imagine that you were for the sake of discussion. If it was a very, very good simulation, then what would it look like? It would look exactly like reality. So you would never be able to tell the difference between the two cases if that was so. Now, of course, nobody really thinks that you're in a simulation, so I don't find this to be a very problematic assumption of science. It's just assuming the same thing that everyone, I would hope, assumes, unless you've been wondering this whole time, am I living in a dream? You probably would agree that there's an external reality for us to discover and that we can do that even if it's not absolutely provable. Okay, so one assumption of science that's sometimes called a limit, but I don't see it as a very problematic limit, if anything. And another limitation of science that is discussed in the book is that it can only study and describe the things which are observable. So if there are any things that are not observable, then it would be very difficult for science to ever comprehend what it is. So another limit that some people worry about is that science is only able to describe or discuss things that are somehow observable, whether directly or indirectly. So if there were any things that were outside of the ability for us to observe, then science could never ever contemplate them or try to discover what they're all about. So for example, if there's anything supernatural like souls or God or the afterlife or psychic powers or ESP, if anything like that exists, then because it's not something that can be studied through observational means, it would never be capable for science to even investigate or to try and explain it. Now, if you're a really scientific-minded person, you might say, well, that's good because these things are all fake and made up anyway, so who cares? But to some anyway, there could be strange phenomena in the universe that are not capable of either direct or indirect observation. And if that's really true, then that's going to be something that science is not going to be able to explore and to research. Even outside of the realm of like the paranormal and the supernatural and the spiritual, there are some scientific questions that this causes problems about. For example, one thing we know is that from our observation of space, it seems that all matter in the universe is getting gradually further away from everything else. So there's an expanding phase going on in the universe. All matter is becoming less concentrated and more diffuse as it expands out into the space of the universe. Now, people aren't sure what's driving this outward expansion of matter, because gravity, as you guys have just discussed, is an attractive force. And so you'd think that that would provide some kind of compensation for the fact that this stuff is expanding out. But the expansion seems to be overwhelming whatever attractive forces there are in the universe, and it's not clear what's causing that. Some people consider the possibility of what's called dark matter. Could dark matter be the thing that's fueling this outward expansion of material in the universe? Well, if it's true that it's dark matter doing it, we won't be able to really understand it too well yet, because dark matter is called dark matter because it's not capable of either direct or indirect observation. So anyway, stuff like dark matter, even if it's a physical phenomenon in the universe, if it's not susceptible to observation, then it's going to remain kind of mysterious and puzzling for scientific researchers. Some things that used to be not capable of direct observation have become observable through the development of new technologies. Like we have electron microscopes and stuff now, so we can actually see the atom, whereas it was a purely theoretical thing for a long time before the 20th and 21st century. We could build cloud chambers, for example, that show the motion and so forth of elementary particles. That allows us to indirectly observe their behavior in ways that was not capable of doing in prior centuries. So some things that are outside the realm of observation will eventually be brought within, according to future technologies and tools we can build. But other things may never be capable of observation, and those would be things that science is limited in analyzing. So another possible limit of science. And also, some people critique the assumption of predictability that we had on the board before, the assumption that the natural laws are stable and that they will never change over time, and that they will remain permanently as such. Obviously, we haven't been in the future yet, so some people say, how can you really guarantee that the behavior of natural laws is going to persist into the future, even if they've been stable for as long as we've had any evidence to observe? How can you really know that tomorrow they will continue to function in the same way? It seems almost like it's induction with no guarantee of the conclusion, as you've learned in an inductive argument. Even if the evidence is very strong for the conclusion, it doesn't guarantee that it's the case. And so some people wonder if we're helping ourselves to too much by assuming that these laws can never change in the future. Okay, so some limitations of science. The next part of chapter 12, we're just going through the notes on this chapter, and I'm trying to walk you through the important points. It talks a little bit about attitudes that people can have about the relationship of science and religion. Okay, so you probably know that at least some will argue that science and religion do not fit well together, that they contradict each other, that they make claims that are contrary to what the other side is claiming. Well, what are the different positions then that a person can have when it comes to these apparent conflicts between religion and science? There's 4 basic attitudes. So here we go, 4 views on the relationship between science and religion. Okay. So one of these views, first one mentioned, is that science takes priority over religion when the two things conflict. Okay, so science taking priority over religion when they conflict. Okay, so sometimes it seems that science and religion make claims that are opposite of each other. For example, in one way of looking at religion, it's said that God created the universe and created man in his image. So that's creationism. And according to creationism, there's no evolution. God just made human beings fully formed in the image that he has. Of course, now, according to science, that's not true. According to science, there was no Garden of Eden where there were like the first 2 human specimens, and then from that, all the rest of us issue. Instead, it's this story of very gradual process of natural selection over millions of years to eventually generate mammalian, vertebrate, bipedal life forms and Homo sapiens. So what's the case? Is it creationism or is it evolution? If you hold this perspective, then you're going to break in favor of science when such conflicts arise, okay? So if science says it's evolution and the Bible or whatever says, no, that's not the case, instead it was creationism by God, if those two things are conflict to each other, if they don't agree, then the person who holds this position will favor the scientific explanation and reject the religious one. Some religious texts claim that the planet Earth is only like 5,000 years old, but science says that according to fossil data that we can carbon date, this is totally not true, and that there are, fossilized remains of dinosaurs from the Jurassic and Cretaceous period that are millions and millions and millions of years old. So if a scientific account says that the planet Earth is at least millions of years old, and some religious account says, no, it's rather a few thousand years old, then anybody who positions themselves this way would prefer and prioritize the scientific answer over the religious one. So basically this view, to simplify, is that if someone is in this way of thinking, when science and religion don't go together, the person goes with science, and they prefer that. They say science wins when they don't agree. But that's not the only view that a person could possibly have. Obviously, there's the reverse, which would be the opposite, to say that religion takes priority over science when the two conflict. So like the other one, that would be view number 1, and view number 2 is just the same, but we're swapping these two words out. So the second position would be that religion takes priority over science when the two conflict. And you see people who hold that view as well. We're just talking about the options that people have. One option is to be in favor of science when there are conflicts. Another possible position is to be in favor of religion when there's some conflicts like those. So if you hold this position, then in the same cases I just mentioned, you'd say, no, the scientist is wrong and the theist is correct. So if science is telling me that the universe is billions of years old and that man did not appear at the beginning, and religion contradicts that, I'm going to go with religion and say the science community is somehow misinformed or misperceiving the available evidence. Okay, so a person that's more like devout and fundamental and traditional about their religious views would perhaps reject scientific claims in favor of the religious explanation when the two things come into conflict. And you guys know that that's another option, and some people take this. There's also 2 more possibilities. And the last 2 try to somehow meet in the middle or not necessarily prioritize one or the other. So the third view says this, that science and religion don't really come into conflict because they're dealing with different topics. So science and religion deal with different topics. And so therefore they don't conflict. Okay, science and religion, they're dealing with different topics, and so they don't conflict. So maybe you've heard some people say things like this. Well, religion and science, they're in their own different lanes. They really don't overstep their individual boundaries because they're focused on different subject matter. For example, in science, that's where you go if you want to learn about how things work, how cause-effect processes in nature work. So if you want to understand like the mechanical or physical principles of a observable phenomenon, you would go to science. But if you want to know about the spiritual side of life, morality, your values, then you would go to religion. So like religion deals with the subjective and the spiritual and the moral, and science deals with the objective and the physical and the material. So that's one other possible way for people to go. The only issue with this option, though, is that it's not so easy to really disentangle the areas where the two things seem to be talking about the same topic. After all, science has accounts of the origin and genesis of mankind and the universe. and the position of the earth, etc. And religion has, in some practices, its own views on those same questions that don't always agree. So how can we really say that science and religion are not dealing with the same topics when, for example, one will say that mankind was created in the image of God, and the scientific community says, no, we have evolved from higher primates. In some cases, it seems like they're dealing with the same topics. So although this is an appealing option to try and just keep them separate so that they don't encroach on each other, in the areas where they do seem to talk about the same material, it's hard for us to hold fast to this position. But a fourth view, and the last one mentioned in the text, is to say that science and religion are compatible. Now, this is a way of saying that the supposed disagreements between the two are just illusory. So there's no real disagreement between the two. In fact, they say the same thing in the end if you just interpret religion properly. So for example, in the Bible where it says in Genesis that God creates the universe in 7 days and on the seventh day he rested. And then in the scientific community, it says, no way, it took billions of years even for gas to accumulate to form stars, and then for planets to accumulate mass so that we can even have life forms. What's the case? Is it 6 days of creation, or is it billions and billions of years for even just life to start? Well, one might say, look, it looks like it's a contradiction, but maybe when it says in the Bible that God created the universe in 6 days, those days don't refer to like a 24-hour day, but just some arbitrary unit of time. Like it could be billions of years, millions of years, but the biblical author just uses the term day as a generic phrase. So maybe what looks like a contradiction is no longer a contradiction once we finesse or the interpretation of the scriptures so that it comes into alignment with whatever the scientific community has discovered. I find that that's a popular option, like another case, evolution or creationism. Someone might say, okay, well, it looks like that's a disagreement, but maybe God just created evolution and he knew what the end product of evolution would be. So creating us in his own image still is consistent with what the scientists have discovered out there in the field. I see that this is another appealing option because it allows you to say, I don't want to have to pick sides. I just want to embrace both. But to some anyway, it looks a little disingenuous because the modification of the religious interpretation always happens after the scientific discovery. Right? Think it's again like heliocentrism and geocentrism. Nobody was questioning whether the Earth was in the middle until scientific investigators discovered through telescopes that that was the case. And then the church modifies the doctrine afterwards. But it's not like they had anticipated in advance, hey, is this really the right way to interpret scripture? Maybe we're not in the middle. Only after the scientific discovery puts pressure on the traditional interpretation of the text does the religious community concede that maybe there's a different way of looking at it. So sometimes you might say that this is a little bit post hoc, making ad hoc changes to religious doctrine just to conform to whatever science has discovered so that the conflicts disappear. But anyway, guys, wherever you stand, you're going to hold a position somewhere in that matrix of options, either being more favorable to science, more favorable to religion, thinking that they're in their different lanes, or that they actually agree in the end. So it's just interesting food for thought, but we have more on the same topic of science for Thursday. So just make sure that you've read the whole chapter, and we'll finish it out with a little bit more notes on Thursday, and then next Tuesday, a week from today, we'll have the quiz on this same chapter. So I guess we're out of time for now. Let me know if everything's good, and I'll just close the stream. Thanks, guys, for being up and helping making it interesting. But let me know, and then once I see your reaction, I'll just close this out. Okay, thanks again, Nicole. Appreciate your help. And to all the rest, perfect. Have a good one. If you need anything, email me. I'll be checking my emails. Have a great day, and see you soon. Okay, bye-bye.